All right, so as promised, we're actually going to do a little bit more than just definitions in this lesson. So we're talking about frequency distributions. So way back in our first lesson, we talked about how the three main steps are to prepare the data, analyze the data, and then hopefully draw conclusions from the data. So here we are still in the preparing and moving toward analyzing, because when we organize it, that allows us to analyze it. So we still have some definitions, that's not going to go away, but we are going to start to get a little more math involved. So definitions that are important, if we want to create a frequency distribution, probably important that we know what it is. A frequency distribution is a simple chart that shows the categories, which we call classes, that data are divided into, as well as their frequencies, meaning how many of our sample or of our population fall into that particular class or that particular category. With the classes, we are going to have lower class limits, upper class limits, class boundaries, class midpoints, class width. They all have the word class in them. Obviously really important because some of these definitions are used for actual calculations. So it's important that you know what these definitions mean so that when you're asked to use, a lower class limit to do a calculation, that you choose the right number. So the lower class limit is the smallest numbers that can belong to each of the classes. The upper class limit, as you might imagine, are the largest numbers that can belong to each of the classes. Class boundaries are a number that would separate the classes without gaps. Usually, class boundaries are going to be decimals. So if, let's say, our first class, the lower limit is 1 and the upper limit is 9, that would mean that the smallest number that would put something in that class is 1 and the highest number that could be in that class is 9. So then it's possible that the next class might start with 10, for instance. So my first class was, say, 1 to 9, and then my second class starts at 10. If that's the case, then the class boundary would need to be a number that would separate 9, which is the upper class limit of the first class, and 10, which is the lower class limit of the second class. So in that case, we would probably choose 9.5. But it's possible that your class limits are decimals. So if your upper limit is, 2.5, and then, the next class starts at 2.6, then you might choose 2.55. So usually they're decimals and they're, 1 decimal place past typically whatever the decimal is on the class limits. Class midpoints are just like they sound. Those are the values that are in the middle of the classes. These you actually have to calculate, and we do that by taking the lower and upper limits, adding them, and then dividing by 2. Class width is the difference, which means subtraction, between two consecutive lower class limits. First of all, I always get people that when I ask them what the class width is, they do the upper class limit minus the lower class limit. That's not going to give you the right answer. You have to use two lower class limits and subtract them to find out what the class width is if you already have a frequency distribution. If you're creating a frequency distribution from the data itself, the way that we would determine a class width is typically to take whatever the maximum value is, subtract the minimum value, and divide by the number of classes. And then round to a convenient number that doesn't leave out any data. So if when you do max minus min divided by number of classes, let's say you get, 9.5. Well, if you round up and you make it 10, if that's going to leave out any data or cause you to either start or end with an empty class, first, last, class empty, then you need to choose something else to round to. So it can't just be a convenient number that's whatever you want. It's a convenient number that doesn't leave out any of the data and doesn't have a first or last class that's empty, meaning a frequency of 0. What are the benefits of a frequency distribution? So why would we want one of these, in other words? First would be that this helps us to summarize large data sets. So we can analyze and or draw conclusions more quickly when I'm looking at something in a frequency distribution than if I'm just looking at the whole list of data, especially the bigger the list gets. If I'm looking at 100 individual numbers, it's going to be really hard for me to just draw a conclusion quickly. But if I'm looking at those 100 pieces of data organized into a frequency distribution, then in a matter of seconds I can come up with some, observations that are meaningful. The other things that it allows us to do is to identify outliers. You can see them pretty quickly. We can see the shape of the distribution, which we'll talk more about shapes in further sections. We'll talk about one particular shape today. And then we also sometimes use the frequency distribution as a basis for certain types of graphs. All right, so if we are creating our frequency distribution, first we determine how many classes we're going to use. Typically this is 4 or 5. Then we calculate the class width, so we already talked about how to do that. Round up to a convenient number. Again, I'm going to underline this in a different color. Make sure that whatever you're rounding to doesn't leave out data or leave a class empty. Then once we've figured out the class width, you're going to choose the value for the first lower class limit. I would suggest using either the minimum or a convenient number below. Again, keeping this in mind, that whatever you decide, we can't always start at 0. It'd be nice if we could, but if we always start at 0, we can't always follow the guidelines. Once you've chosen the first lower class limit, because class width is defined as the difference between two consecutive, so let's say that our class width is 20 and our first lower class limit is 1, then that means I'm going to add 20 to get the second class. So second class would start at 21, then 41, then 61, so on and so forth. So you can list your other lower class limits. Once you've done that, then you'll be able to determine and enter the upper class limits. So in the example I just gave, if my next class starts at 21, it would make sense that the class before it ends at 20, for instance. Then we look at the data, determine, record the frequencies for each class. So meaning how many elements of data subjects do we have in that particular class. Once we know how to create a frequency distribution, we then have two additional variations that you need to be able to create. And those are relative frequency distributions and cumulative frequency distributions. So we'll do that in the example here. Since we're getting a little more mathy, we'll actually go through these steps here so you can see the difference between all of these as well. But a relative frequency distribution is a frequency distribution where instead of displaying the frequencies themselves, we have either proportions or percents. So proportion would be a fraction or a decimal. So instead of having the actual number of times that particular class appears, we would have the percentage or the decimal or the fraction of times that it appears. When you have a relative frequency distribution, you need to make sure that the sum of all of those relative frequencies should be very close to 1 if we're talking proportions, or 100% if we're talking about percentages. Because if it doesn't, then there's something wrong. It doesn't make sense. A cumulative frequency distribution is where instead of the frequency for each class being how many times, numbers in that class appear, it's how many times those and the ones before. So it's the frequencies for each class is the sum of the frequencies for that class and all the ones before. All right, so in this video, I am going to use class data from a previous semester, since I obviously couldn't collect data right now from you in order to do this video. So the question that I had asked the class is how many minutes, rounded to the nearest minute, prior to the start of your first class, did you leave your house? So on a particular day, if your first class started at 7:55, how many minutes before 7:55 did you leave your house? If your first class didn't start till 9 o'clock, how many minutes before 9 o'clock did you leave your house? So that's what I had asked, and this is the data that I had collected. So 1, 2, 3, 4, 5, 6 times 4, so I have 24 pieces of data. So I had 23 students plus me included in this data. So you can see it's not ordered. This is just, people calling out to me, their particular data, or, going up to the board and putting their post-it up there. So when I look at this, if I want to create a frequency distribution, and you can see by the way I've set it up that in this case we're going to use 5 classes. Almost all of the time, if you're creating it, they tell you how many classes to use. So We're going to be using 5 classes because that's how many spaces we have. So that's already done for us, number 1. Number 2, calculate the class width. So again, class width, I do max minus min divided by the number of classes. So as I look through all of this data, the maximum is 85. The minimum that I see here is 4. Whew, people must live very close. So I'm going to do 85 minus 4 divided by my number of classes, which is 5. So pull up my calculator here. So 85 minus 4 we know to be 81. So I'm going to take 81 divided by 5, and I get 16.2. So when I say round up to a convenient number, that doesn't necessarily always have to be the next whole number. It could be. So your frequency distribution that you create on a homework may not be the same as somebody else's, and they could both be right. Just make sure you've read all the directions, because sometimes they'll not only tell you how many classes to use, but they might tell you the class width to use as well. In this case, it'd be awfully nice if I could maybe use 20s instead, just because it's quick and easy to count by 20s. So I would love to be able to make this 20, but I have to check to make sure it's going to work if I do that. So if I use a class width of 20, and let's say that I start at 0, that would mean this would start at 0, this would start 20, 40, 60, 80. So I would need to make sure that I don't have any empty classes. Well, if this starts at 20, that would mean that this one would end at 19, because we said rounded to the nearest minute. And so this would not be an empty class. Also, that means that this, because if I had a 6th class, it would start at 100. This would end at 99. This would not be an empty class either, because my biggest number, 85, falls in that range. So that means that in this case, I can go ahead and make it 20 if I want to make this a more convenient number. So that means that this, because these are going to count by 20s as well, or you can just look one below. And so now I've got all my classes set up. Frequency means I actually need to count how many I have. So how many of the people surveyed left their house between 0 and 19 minutes before their first class. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 0 to 19 minutes has a frequency of 19. Now I look for 20 to 39. So 20 to 39, here's one. So 1, 2, 3, 4. So frequency of 4 here. 40 to 59. When I look here, I don't see any. So that's a 0. That's okay. You're allowed to have empty classes as long as they're not the first or the last. So that's why I chose something like this on purpose, so we would have some empty classes. There's also nothing between 60 and 79. And then I've got the 1 in that last class. So this would be my frequency distribution. Now, if I was doing a relative frequency distribution, then I would just recreate, let's see, it's not going to be perfect because I don't have all the same tools as when I originally typed this, but be a little better than just completely freehanding it. So number of minutes, we'll just put, and relative frequency. So in this case, we are still going to have the same 5 classes with the same labels. But now we're either going to have the decimal or the percent. So 19 out of those 24. So 19 out of 24. So I would say approximately 79.2%. Or, you can just do 0.79 if you were looking at proportion. So about 79.2%. 20 to 39 is 4. So again, we're talking about the proportion, so meaning out of the total. So 1/6, which is 16.7% approximately. Then these two are easy, 0%. And then the 1 out of 24 to wrap up the relative frequencies, which would be about 4.2%. So this would give me about 21-ish total, plus about 80, which gives me about 100%. It's okay if it's 0.1% over or under, because we rounded these numbers. So you see here it's going to come out to 99, or no, 100.1%, and that's okay. If it comes out as 99.9%, that's okay too, as long as it's really, really close. So this would be a relative frequency distribution. A cumulative would be if, for instance, instead of just having those same classes, now you can still label them the same way, but usually on a cumulative, for the number of minutes, it will change, and it will either say like up to 19, or it might still say 0 to 19, but then the next one, instead of saying 20 to 39, it usually will say 0 to 39 because it's cumulative. Or it might say up to or less than 39. So sometimes they use words, sometimes they use numbers, but usually they're going to change that left-hand column. And by the time we get to the bottom, this is our cumulative frequency. So this is still 19, but then the next one, it's the sum of that, which is 4, and all the classes beforehand. So this would be 23. If I add 0, it's still 23, still 23. When you get to the bottom, it should be however many total pieces of data you have. So hopefully the differences between those three make sense. We obviously use the frequency distribution most, but it is important that you know how to create the other two as well. Last definition is that of a normal distribution, which you hear talked about all the time in real life. This is normally distributed. normal distributions are distributions where the frequencies start low, then increase to one or two high frequencies, then decrease back to low. And in addition to the low, high, low, it has to be approximately symmetrical, meaning that those high values in the middle should have symmetry, the middle ones, should have symmetry, and the ends should have symmetry. The typical way that we describe a normal distribution is a bell-shaped curve. So the general shape, low, high, low, and approximately symmetrical. Doesn't have to be exact, but approximately. So you can see this, I can tell by my frequency distribution, definitely not normally distributed, because my frequencies are, way higher on the left side and very low on the right side. All right, I think that about wraps it up for section 2.1.